Namaste students. Before we start today's class, we shall recall what a real number is. A real number is either rational or irrational. A rational number is in the form of p by q, where p and q are integers and q is not equal to 0. Whereas an irrational number cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. Today we are to learn real numbers and their decimal expansions. There are a few points to be known. For a rational number p by q, if the decimal expansion terminates or ends, we call it as terminating decimal expansion. An example is, on dividing 7 by 8, we get the exact value 0.875, that is, the remainder is 0. So, 7 by 8 as the terminating decimal expansion. Note the next point. If the decimal expansion is not terminating and the same set of digits are repeated, then it is said to be non-terminating and recurring decimal expansion. An example is, on dividing 1 by 7, the remainder never becomes 0, that is, the remainders repeat after a certain stage such that a block of digits 142857 is repeated in the quotient, that is the decimal expansion, and is represented as 0.142857 142857 ... That is, the dot represents that the decimal expansion do not terminate or end. It can also be written as 0.142857 bar, where the bar above the digits indicates that the set of digits is repeating or recurring. Hence, 1 by 7 as a non-terminating recurring decimal expansion. Next point. For an irrational number, the decimal expansion will be non-terminating and non-recurring. An example is, root 2 is an irrational number as you have learned. The decimal expansion is 1.414213562375004888 ... where we observe that the decimal expansion is non-terminating and non-recurring also. Hence, root 2 as a non-terminating and non-recurring decimal expansion. Now, we will do example sums based on this. Example 5. Find the decimal expansion of 10 by 3, 7 by 8 and 1 by 7. First, 10 by 3. 10 divided by 3. Start dividing. 3 3s are 9. 10 minus 9, we get the remainder as 1. Since we require the decimal expansion, place a decimal dot in the quotient such that we can add the required zeros in the dividend. Now, the remainder becomes 10, and now start dividing. 3 3s are 9. Again we get the remainder as 1, add a 0, and again 3 3s are 9. Again we get the remainder as 1 and add a 0 such that again it becomes 3 3s are 9. Again we get the remainders 1. Now what is that we note here? We see that the remainders get repeated again and again, that is 1 gets repeated. And in the decimal expansion, that is the quotient, 3 gets repeated again and again. So we have represented it as 3.333 ... Hence, 10 by 3 is equal to 3.333 ... which is equal to 3.3 bar, which is non-terminating recurring decimal expansion. Now we shall do the second sum, 7 divided by 8. 7, the dividend is lesser than the divisor. So how is that we divide? We have to place a decimal dot, that is 0 point in the quotient, in order to add zeros to the dividend to start to divide. Now add 0 to 7 such that it becomes 70. 8 divides 70 8 times, that is 8 8s are 64, and when you subtract 70 minus 64, you get the remainder 6. Add 0 to 6 such that 8 divides 60 7 times, and it becomes 60 minus 56 is equal to 4. Add 0 to 4 such that 8 divides 40 5 times, and it becomes 8 5s are 40, and the remainder becomes 0. Observe that the decimal expansion, that is the quotient, is also terminated. We have got 0.875. Hence, 7 by 8 is equal to 0.875, which is a terminating decimal expansion. Now we are to divide 1 by 7. On dividing 1 by 7, you can see on the right, we get the remainder 1, which is the same as the dividend in the beginning. That is, the division process repeats the same as you get the remainder 1. And what happens to the quotient? The decimal part in the quotient, that is 142857, will get repeated, that is, it recurs. So what kind of a decimal expansion is it? It is non-terminating recurring decimal expansion. How is that we are going to express? 1 by 7 is equal to 0.142857, that goes on, which is equal to 0.142857 bar, where the bar indicates that a set of digits it's getting repeated. Now what kind of a decimal expansion is 1 by 7 is a non-terminating recurring decimal expansion. Now we will do the sixth example. Show that 3.142678 is a rational number. In other words, express 3.142678 in the form of P by Q, where P and Q are integers and Q is not equal to 0. We have learnt in our earlier classes how to make a decimal a rational number, that is P by Q. Now, in the numerator becomes 3142678 by removing the decimal. In the denominator, the number of decimal places, that is 6, becomes the number of zeros followed by 1. So it becomes 3142678 by 1 followed by 6 zeros. Now both the numerator and the denominator gets cancelled by 2, that is, it gets reduced. So both are divisible by 2, that is, it becomes 1571339 by 5 followed by 5 zeros, which is in the form of P by Q, where P and Q are integers. Hence, 3.142678 is a rational number. Example 7. Show that 0.3333 dot is equal to 0.3 bar can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. We do not know what 0.3 bar is. Let us assume x is equal to 0.333 dot and let it be equation 1. Now in 0.333 dot 3 is repeated once, and so multiply both sides of equation 1 by 10. 10 into x is equal to 10 into 0.333 dot. Now left hand side 10 into x becomes 10x. Right hand side the decimal moves one place after 3 and it becomes 3.33 dot and let it be equation 2. Now equation 2 minus equation 1 implies 10x minus x is equal to 3.33 dot minus 0.33 dot. Now 9x is equal to 3. So x is equal to 3 by 9, which is equal to 1 by 3. Therefore 0.3 bar is equal to 1 by 3 is a rational number. Example 8. Show that 1.272727 dot is equal to 1.27 bar can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Now let us assume x is equal to 1.272727 dot and let it be equation 1. Now in equation 1 you can see after the decimal 2 digits are getting repeated. So we have to multiply both sides of equation 1 by 100. Now 100 into x is equal to 100 into 1.2727 dot dot. 100 into x becomes 100x is equal to, now on the right side the decimal moves 2 places after, so it becomes 127.2727 dot dot, and let it be equation 2. Equation 2 minus equation 1 implies 100x minus 1x is equal to 127.2727 dot dot minus 1.2727 dot dot. 99x is equal to 126. So x is equal to 126 by 99, where it gets reduced and both the numerator and the denominator is divisible by 9, and it gets reduced to 14 by 11, which 1.27 bar is equal to 14 by 11 is a rational number. Example 9. Show that 0.2353535 dot dot is equal to 0.235 bar can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Let us assume x is equal to 0.2353535 dot dot, and let it be equation 1. Now note that 2 is the non-repeated digit after the decimal and 35 other repeated digits. Now first bring the non-repeated digit to the left hand side of the decimal. Multiply both sides of equation 1 by 10 since there is only one non-repeated digit. 10 into x is equal to 10 into 0.2353535 dot dot. 10x is equal to 2.3535 dot dot, and let it be equation 2. Now in equation 2, note that 35 is the repeated digit after the decimal. So multiply both sides of equation 2 by 100 in order to bring 35 to the left hand side along with 2. 10x into 100 is equal to 2.3535 dot dot into 100. 1000x is equal to 235.3535 dot dot, and let it be equation 3. On subtracting equation 2 from equation 3, that is equation 3 minus equation 2 implies 1000x minus 10x is equal to 235.3535 dot dot minus 2.3535 dot dot. 990x is equal to 233. X is equal to 233 by 990. Now both the denominator and the numerator do not get reduced. So therefore 0.235 bar is equal to 233 by 990, which is a rational number. Example 10. Find an irrational number between 1 by 7 and 2 by 7. 1 divided by 7. 1, the dividend is lesser than the divisor. So we have to place a decimal dot in the quotient and start adding zeros to proceed the division. 1, the dividend becomes 10. 7 divides 10 one time, that is 7 ones are 7. 10 minus 7, 3. So add 0 to 3 such that it becomes 30. 7 divides 30 4 times. 7 4s are 28 with the remainder 2. Add 0 to 2 such that it becomes 20. 7 divides 20 2 times, that is 7 2s are 14 and leaves a remainder 6. Add 0 to 6 such that 7 divides 60 8 times, 7 8s are 56 and leaves a remainder 4. Add 0 to 4 such that it becomes 40. 7 divides 40 5 times, that is 7 5s are 35, leaves a remainder 5. Add 0 to 5 such that 7 divides 50 7 times, that is 7 7s are 49 and leaves a remainder 1. Now see, this 1 becomes the same as dividend 1, and it is understood that the division proceeds the same way, and also the decimal expansion in the quotient gets repeated, that is 142857 gets repeated. So now 1 by 7 is equal to 0.142857 bar, where the bar indicates that a set of digits 142857 gets repeated. Next, 2 by 7 can be splitted as 2 into 1 by 7, which is equal to 2 into 0.142857 bar, which when multiplied gives us 0.285714 bar. Now to find an irrational number between 1 by 7 and 2 by 7, we find a number which is non-terminating and non-recurring lying between them. That is, we can find infinitely many such numbers that lie between 0.142857 bar and 0.285714 bar. An example of an irrational number between 1 by 7 and 2 by 7 is 0.185236 dot dot. That is, I have selected a number 0.18 between 0.14 and 0.28 and added different digits to it to make it as non-terminating, non-recurring. Now we will solve sums in exercise 1.3. Write the following in decimal form and say what kind of decimal expansion each has. Before we start, recall once more what is learned. On dividing p by q, if remainder becomes 0, then the decimal expansion is terminating. And if remainder never becomes 0 and set of digits repeats periodically, then the decimal expansion is non-terminating, repeating. Now we will go on to the first sum, 36 by 100. Now in 36 by 100, since the denominator is 100 and as 2 zeros, shift the decimal dot in the numerator to the left 2 places before, such that we get the exact value for 36 by 100 as 0.36. That is, the remainder becomes 0. Therefore, 36 by 100 is equal to 0.36 is a terminating decimal expansion. Now we will do the second sum, that is 1 divided by 11. 1, the dividend, is lesser than the divisor. Put 0 point in the quotient and add a 0 to 1 such that it becomes 10. Again 10 is lesser than the divisor 11. So add a 0 after the decimal in the quotient and put a 0 to 10 such that it becomes 100. 11 divides 100 9 times, that is 11 nines are 99 and 100 minus 99 gives the remainder 1. Now what do we observe? 1, the remainder is the same as the dividend in the beginning. What happens? The division process becomes the same again. So the remainder never becomes 0. What happens in the quotient? The decimal expansion, that is 09, gets repeated again and again, and the decimal expansion do not terminate. Hence 1 by 11 is equal to 0.09 dot dot dot, which can be also represented as 0.09 where the bar indicates that 09 is getting repeated again and again. Hence it as, that is 1 by 11 as a non-terminating recurring decimal expansion. Now the third sum is 4 and 1 by 8. 4 and 1 by 8 is a mixed fraction. As we have learnt in your earlier classes, mixed fraction is to be converted to improper fraction. 8 fours are 32, 32 plus 1 is 33 and it becomes 33 by 8. Now we will do the division part, that is 33 divided by 8. 8 divides 33 4 times, that is 8 fours are 32 and 33 minus 32 gives the remainder as 1. Now we require the decimal expansion, that is the quotient. So we have to place a decimal dot and add the required zeros to the dividend. Now what happens is we have to add a 0 to 1 such that it becomes 10. 8 divides 10 one time, that is 8 ones are 8 and 10 minus 8 gives the remainder as 2. Add 0 to 2 such that it becomes 20. 8 divides 20 2 times and 20 minus 16 gives the remainder as 4. Add again 0 to 4 such that it becomes 40. 8 divides 40 5 times, that is 8 5s are 40. 40 minus 40 gives the remainder as 0. that is the remainder has become 0. Now the division is terminated. So the decimal expansion, that is the quotient, is also terminated. Hence 33 by 8 is equal to 4.125. Hence it has, that is 33 by 8 as a terminating decimal expansion. Next is 3 by 13. 3 divided by 13. See that 3, the dividend, is lesser than the divisor. So we have to put 0 point in the quotient and add 0 to 3 such that it becomes 30. Now 13 divides 30 2 times, that is 13 2s are 26, and 30 minus 26 gives the remainder 4. Now add a 0 to 4 such that it becomes 40. 13 divides 40 3 times, that is 13 3s are 39, and 40 minus 39 gives the remainder 1. Now again add a 0 such that it becomes 10. Observe that 10 is lesser than the divisor. So put 0 in the quotient and add another 0 to 10 such that it becomes 100. 13 divides 100 7 times, that is 13 7s are 91, and 100 minus 91 gives the remainder 9. Again add a 0 and such that it becomes 90. 13 divides 90 6 times, that is 13 6 are 78, and 90 minus 78 gives the remainder 12. Now add a 0 to 12 such that it becomes 120. 13 divides 120 9 times, that is 13 9s are 117. 120 minus 117 gives the remainder 3. Now what do you observe? See the remainder. That 3 is the same as the beginning of the division, that is the dividend 3. That is, the division process continues as it is from the beginning. So the remainder never becomes 0. Imagine if you add 0 to 3, again it starts from the decimal, that is 2. So what happens in the decimal expansion, the quotient? The set of digit 2, 3, 0, 7, 6, 9 will get repeated again and again. So the decimal expansion do not terminate, but a set of digit gets repeated. So 3 by 13 is equal to 0.230769 ... which can be represented as 0.230769 bar, where the bar represents the set of digits being repeated again and again. Therefore, 3 by 13 as a non-terminating recurring decimal expansion. Now, we have to convert 2 by 11 to decimal expansion and say what kind it is. Divide 2 by 11. 2 is lesser than the divisor, unable to divide, place a decimal dot in the quotient, add 0, it becomes 20. 11 divides 20 one time, that is 11 ones are 11, and you get the remainder as 9. Now again add 0, and 11 divides 98 times, that is 11 8s are 88, and you get the remainder 90 minus 82. Now what do you observe here? 2, the remainder is the same as the dividend in the beginning. Now stop dividing. So once it gets repeated, stop dividing, and what happens? The division process becomes the same as before. What happens to the decimal expansion, that is the quotient? In the decimal expansion also 1/8 gets recurred. So for that record we have put the symbol as ... Now how do you express it? 2 by 11 is equal to 0.18 ... Since it is non-terminating and recurring, you tell it as a non-terminating recurring decimal expansion. Now next is we are going to find out what kind of a decimal expansion is 329 by 400. 329 is lesser than the divisor. Place 0 point in the quotient and add 0. So 3290 goes in 408 times, that is 400 into 8 you get 3200. On subtracting you get 90, add 0 such that it becomes 900. 400 into 2 you get 800, so 900 minus 800 you get 100. Now add a 0 such that it becomes 1000. 400 divides 1000 2 times, that is 400 into 2 you get 800. 1000 minus 800 you get 200. Add 0 such that it becomes 2000. 400 divides 2000 5 times, that is 400 into 5 you get 2000. So what is the remainder now? The remainder is 0. Now the division has terminated, and also the decimal expansion in the quotient also gets terminated. So what kind of a decimal expansion it is? It is a terminating decimal expansion. So 329 by 400 is equal to 0.8225, such that it is terminating decimal expansion. The second question is, you know that 1 by 7 is equal to 0.142857 bar. Can you predict what the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? If so, how? Hint they've given you as, study the remainders while finding the value of 1 by 7 carefully. Now first of all, before getting into the solution, we will know about the hint what is given over there. That is, on dividing 1 by 7, the remainder 1 would have been, that is, become the same as dividend. So it meant the division process becomes the same as it is from the beginning. So the decimal expansion in the quotient gets recurred. That is 142857 gets repeated. So that's why 1 by 7 is equal to 0.142857 bar. Now we will go on to the solution. 2 by 7 is equal to 2 into 1 by 7. That is, 2 by 7 is getting splitted as 2 into 1 by 7. We know what is the value of 1 by 7. So we can substitute in that place as 2 into 0.142857 bar, which when you multiply it, you get the solution as 0.285714. 3 by 7 is splitted as 3 into 1 by 7, which gives you 3 into the value of 1 by 7, that is 0.142857 bar, that when you multiply you get it as 0.428571 bar. 4 by 7 is splitted as 4 into 1 by 7. Since you know the value of 1 by 7, we can write it as 4 into 0.142857 bar, where when you multiply you get it as 0.571428 bar. And that bar represents that a set of digits is getting repeated. Now 5 by 7 is equal to 5 into 1 by 7, that is, it has been splitted, and 5 into 0.142857 bar is equal to, when multiplied you get it as 0.714285 bar. 6 by 7 is equal to 6 into 1 by 7, that is 6 by 7 is splitted. Now multiply 6 into 0.142857 bar, that is, since the value of 1 by 7 is 0.142857 bar. Now when multiplied you get 0.857142 bar. Next is, express the following in the form of P by Q, where P and Q are integers and Q is not equal to 0. The first division sum is 0.6 bar. 0.6 bar should be expressed in the form of a rational number P by Q. Now we will get on to the solution. Since we do not know what 0.6 bar is, let us assume x is equal to 0.6666 goes on, that is as equation 1. Now you can observe that in 0.6666 dot we get, that is, only one digit 6 is getting repeated. So we have to multiply both sides of equation 1 by 10. So on the left hand side, 10 into x, you get 10x is equal to 10 into 0.6666 dot. 10 into x, you get it as 10x as I told you, and on the right side 10 into 0.6666 dot dot, you get it as, that is, since 0.66 dot is multiplied by 10, the decimal dot moves to the right one place after, such that it becomes 6.666 dot dot, and let it be equation 2. Now, to find out the rational number, we have to subtract equation 2 and equation 1. So, equation 2 minus equation 1 implies 10x minus x is equal to 6.666 dot minus 0.666 dot, which gives you 9x is equal to, that is 10x minus 1x is equal to 9x is equal to, when you subtract the right side, you get the solution as 6, where x is equal to, when you bring 9 to the right hand side, it becomes 6 by 9, and again x is equal to, when you cancel 6 and 9, both goes in 3 times table, and you get 2 by 3. Now finally again you cannot reduce it. So therefore 0.6 bar is nothing. It is equal to 2 by 3, which is a rational number. Next is 0.47, that is 7 bar, is to be expressed as a rational number. First of all, let us assume x is equal to 0.4777 dot dot. That becomes equation 1. Now in the decimal, that is on the right side of the equation 1, you can see 4 is the non-repeated digit, only number. And 7 is the repeated digit that recurs. And 7 is the only number that gets repeated. Now first of all, we have to shift the non-repeated digit 4 to the left hand side. So it is the only digit, so multiply both sides of equation 1 by 10. By multiplying, you get 10x is equal to 10 into 0.4777 dot dot, and when you multiply, you get it as 10x is equal to, when you shift one place after the decimal dot, since it is multiplied by 10, you get it as 4.777 dot dot on the right side of the equation 2. So 10x is equal to 4.777, that goes on, becomes equation 2. Now here next we have to shift the repeated digit, that is 7, to the left hand side. So only one digit is getting repeated or recurred. So multiply both sides of equation 2 by 10. So now the left hand side of the equation 2 becomes 10 into 10x is equal to, on the right hand side it becomes 10 into 4.777, and that goes on. Now 10 into 10x gives you 100x is equal to, now since the decimal is multiplied by 10, one place after the decimal dot gets shifted, so it becomes 47.777 dot dot, which becomes equation 3. If 3 equations occur, we have to subtract equation 2 and equation 3. Now equation 3 minus equation 2 implies, refer to the before slide, equation 2 and equation 3. Now the left hand side becomes 100x minus 10x, and on the right hand side it becomes 47.777 dot dot minus 4.777 dot dot. Now on subtracting the left hand side, it is 100x minus 10x gives you 90x, and on subtracting the right side, you get 43. Now we have to find out what is the value of x, which is nothing, 43 by the left hand side, since it is multiplied, so 90 comes to the right hand side and gets divided, so it becomes the denominator 90. So 43 and 90 cannot be reduced further. So therefore 0.47, that's 7 bar, is nothing. It is 43.90, which is a rational number. Next we are going to see the third subdivision, 0.001 bar, which we have to express it as a rational number in P by Q form. Now let us assume x is equal to 0.001001 dot dot, let it be equation 1. Now you can see we have removed the bar and we have shown the repeated block of digits over there and kept dot dot, since that is which denotes that it is getting repeated. The dot denotes that it is getting repeated. Now since 3 digits, that is after the decimal place, three digits are getting repeated, we have to multiply both sides of equation 1 by 1000. 1000 into x is equal to 1000x on the left hand side, and on the right hand side 1000 into that decimal becomes 1.001001 dot dot, because when it is multiplied by 1000, 3 places after the decimal dot has been shifted. Now 1000x is equal to 1.001001 dot dot becomes equation 2. Now there are two equations, equation 1 and equation 2. Subtract, that is equation 2 minus equation 1. It implies 1000x minus x gives you 999x on the left hand side. On the right hand side, it becomes 1.001001 dot dot minus 0.001001 dot, which gives you 1. Now we have got 999x is equal to 1. So x is equal to 1 by 999. That is 999 when multiplied by x on the left hand side. When it comes to the right hand side, it becomes the denominator. That is, it gets divided. Now therefore 0.001 bar is equal to 1 by 999, which is a rational number. The fourth sum is express 0.999 dot in the form of P by Q. Are you surprised by your answer? First of all, let us assume x is equal to 0.999 dot, which you have to take it as equation 1. Now in equation 1, you can note that in 0.999, 9 is the only digit that is repeated. So since there only one digit is repeated, so we have to multiply both sides of equation 1 by 10. So it becomes 10x is equal to 10 into 0.999 dot, where since the decimal is multiplied by 10, the decimal dot will go to the right one place after. So it becomes 10x is equal to 9.999 dot, which becomes equation 2. Now equation 2 minus equation 1 implies, that is 10x on the left hand side, 10x minus x becomes 9x, and on the right hand side 9.999 dot minus 0.999 dot becomes 9. Now the equation becomes 9x is equal to 9. So x is equal to 9 by 9. So x is therefore 1. Now what is that we see? We are surprised to see that we are getting an integer, because after decimal 9 is getting repeatedly, it is repeated infinitely, and this will tend to get an integer. Now you can see, because you've got, they've asked you to express 0.999, 9 is getting repeated, so we get the number before the decimal as 1. That is the next number. After 1 comes, we are getting 1. For example, you can take another number, 8.9 bar. In this case, you will get the solution as 9. That is, why is that? Because after the decimal in 8.9 bar, 9 is getting repeated. So the solution, I told you, you'll be getting it as 9, because it is 9 is getting repeated, and the number before the decimal becomes the next number, which is 9. Fifth sum is, what can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. Now, on dividing 1 by 17, as it is on the right hand side, you get nearly 16 steps, and at last you get the remainder as 1. So when we get the remainder as 1, it is the same as it was the dividend 1. So we stop our division. That is, we have known that the remainder do not become 0. And what happens is, the division again, it becomes the same as it is from the beginning. So again, it is understood in the quotient, we have got the decimal expansion, that is after the decimal point, you have got 16 digits, which means on dividing again, you will be getting the same set of digits again getting repeated. So it is going on recurring. So we have kept dot in that, that is, we have kept dot dot in order to know that the same block of digits is getting repeated. So what kind of a decimal expansion it is? It is non-terminating recurring decimal expansion. Now what is that they have asked you in the question? They have asked you what can be the maximum number of digits in the repeating block of digits. So what are the number of digits? That is, what is the maximum number of digits repeating in this block of digits? 16 digits are being repeated. So here in the solution you can write it as 1 by 17 is equal to 0.0588235294117647 bar, where the bar represents that a block of digits is getting repeated again and again. So the solution is the maximum number of digits repeating is 16. We will go on to the sixth sum. Look at several examples of rational numbers in the form of P by Q, where Q is not equal to 0, where P and Q are integers with no common factors other than 1 and having terminating decimal representations, that is expressions. Can you guess what property Q must satisfy? Now I have given you an example 329 by 400, where it is in the form of P by Q. P is nothing 329 and Q is 400. Now you can see this P by Q has no other common factors other than 1, and the solution what you get is 0.8225, where it is understood it is terminating decimal representation as they have told in the question. Now we will see what is Q in the form of. Q is equal to 400, where when you factorize it, you get 2 to the power of 4 into 5 to the power of 2, which is in the form of 2 to the power of m into 5 to the power of n, where m and n are whole numbers. In some cases, when you take P by Q form and where they have no other common factors other than 1 and as terminating decimal representations, the Q will be in the form of 2 by m only, or it will be in the form of 5 by n only. So the prime factors of Q should have only powers of 2 or 5, or it will have both 2 and 5 also. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. The numbers that I have given you is 0.36850127 ... 1.84533029 ... 2.654018 ... Now what can you observe in these examples? The remainder never becomes 0 and the digits are not getting repeated after some interval. So these numbers are non-terminating, non-recurring, and you can even write other numbers as per your choice, such that the remainder should not become 0 and the digits should not get repeated after a some interval. Now the next sum is find the different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Now you know 5 by 7 can be splitted as 5 into 1 by 7. So we already have done 1 by 7 is equal to 0.142857 bar. 5 by 7 is splitted as 5 into 1 by 7, which when you multiply 5 into 0.142857 bar, you get the solution as 0.714285 bar. Now next is 9 by 11. On dividing 9 by 11, you get the decimal expansion as 0.81 ... and you can get the remainder as 9. So the remainder 9 gets repeated, that is it is the same as it is in the dividend. So it is understood the remainder do not become 0. And again, since it is getting repeated, here in the quotient 8-1 also will get repeated. So therefore it is called as non-terminating recurring decimal expansion. You can express it as 0.81 bar. We have to find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. We have found the solution for 5 by 7 and 9 by 11. That means we have to find 3 irrational numbers between 0.714285 bar and 0.81 bar. Now the numbers what you write, the 3 irrational numbers should be in between 0.71 and 0.81. Now the numbers what I have written written here, you can see all the three numbers. In these three numbers, you can see it is non-terminating and none, that is a set of digits is not getting repeated. So it is called as non-terminating, non-recurring. And you can write as per your choice. Now you can see in this 0.74, 0.78 and 0.72 that I have started with is nothing. It is in between 0.71 and 0.81. So you should be careful when you write as per your choice. You should write numbers start only in between 0.71 and 0.81. Now the next one is classify the following numbers as rational or irrational. The first subdivision what they've given you is square root of 23. Now square root of 23, you can see 23 is not a perfect square number. So you will not get a rational number. On finding out the square root, you will be getting, that is, you will not get the remainder as 0, but the quotient what you get will be non-terminating, non-recurring. So therefore it is an irrational number. The second subdivision is to find out whether square root of 225 is rational or irrational. Now here you can see in square root of 225 is a perfect square number, that is it is 15 into 15, you get 15 square. So therefore it is a rational number. Now the third subdivision is 0.3796. Now here you can see the division, that is it is terminated. You do not see the bar or you do not see the dots here. So therefore it is understood the remainder has become 0 and the quotient, the decimal expansion, has also terminated. So therefore since it is a terminating decimal expansion, it is a rational number. The fourth one is 7.478478 dot dot. Now what does that dot dot represent? Either it represents non-terminating recurring or non-terminating non-recurring. But here you see 478 after the decimal, it is getting recurred, it is getting repeated. So but the division is also non-terminating. So therefore you tell it as a non-terminating recurring decimal expansion. Therefore it is a rational number. Now the fifth one is 1.101001000100001. Now in this case dot dot. Now in this case you can see this number 01 and next it is 001 and again it is 0001 and again it is 00001. Now it means it is not getting repeated. If it is not getting repeated, because if it is getting repeated it should be 010101, but it is different. So therefore it is understood the division has not terminated but it is non-recurring also. So therefore it is an irrational number.